Okay, so the leap we're going to make in this section is in a sense fairly simple, but is conceptually vital. If we have a function f of x, and we have a point x sub 0, f of x sub 0, then we have defined f prime of x sub 0, the instantaneous rate of change at x sub 0. And the leap we're now going to make is to use this instantaneous rate of change to define a function. From f of x, we can define f prime of x. And this function takes as its inputs numbers x sub 0 and outputs the instantaneous rate of change of the function f of x at x sub 0. So an example we've done in a previous video, we took the function f of x equals 1 divided by x, and we found the instantaneous rate of change at x0, comma 1 divided by x0. And what we found in particular was that this instantaneous rate of change was negative 1 divided by x sub 0 squared. And then we did an example of that where we were asked to find a tangent line at x equals 4 and to find the slope of the tangent line, we just plugged 4 into this. Well, what we have here then is a function. If we wanted to know the slope of the tangent line at 5, we could just plug it in here. If we wanted to know the slope of the tangent line at, if we wanted to know the slope of the tangent line at -6, we could plug -6 in there and get -1/36. In general, if we want to know the slope of the tangent line at x, we plug x in here and get -1 divided by x squared. The function that takes x and maps it to the instantaneous rate of change at x is f prime of x equals -1 divided by x squared. So previously, this was essentially a formula. It was essentially a function, but we weren't quite thinking of it as a function. We were first fixing x sub 0, and then we were finding the instantaneous rate of change at that fixed value. Here, x is not fixed. X is a variable, and you can plug different values of x in here and get the instantaneous rate of change as the output. So that's the conceptual difference between this section and the last section.